Hello everyone. In this video I am going to demonstrate the modulation of a data signal with a high frequency carrier signal using the ASK technique. The ASK technique or the amplitude shift keying technique is a type of modulation which represents the binary data in form of variations in the amplitude of a signal. So now this is the Arduino Uno board and I am sending RS232 data from the transmit pin of the Arduino Uno. You can see from the transmit pin of the Arduino Uno, and this data is received at the optocoupler. This is the optocoupler MCT2E. The optocoupler is receiving the transmitted data from Arduino Uno. So the output of the optocoupler is fed to the 555 timer IC pin number 4. This is the modulating signal. This is the real data that is received from the optocoupler and it is fed to pin number 4 of Arduino Uno. Pin number 4 of 555 timer IC. So as you can see, the 555 timer IC is wired as an astable multivibrator mode. So it is designed to deliver a frequency of 48 kilohertz. So from the pin number 3 of the 555 timer IC, we are going to get a frequency of 48 kilohertz mixed data signal. So from the pin number 3 we will be getting the final modulated signal, and this signal I am feeding to the envelope detector. You can see here this is the rectifier of the envelope detector, the black one, and here you can see the capacitor and the resistor network of the envelope detector. So I am using 400k resistances. I need 25k resistance. So I am using 400k resistances in parallel to this 0.01 microfarad capacitor. This is an enhancement to the previous video. In the previous video I was using 100k resistance, and as a result the waveform was getting very bad. The capacitor was not able to discharge properly within the time and it was showing bad results. So in this video, this is an enhancement. I have increased this resistance. It is 25k now and it is satisfactory. The results are satisfactory. The output of this envelope detector is fed to op-amp IC. You can see this is LM324 quad op-amp. So one op-amp I am using as unity gain buffer. I am using unity gain buffer because I want to keep my data free from any distortion. I don't want any loading in the signal, that's why I am using unity gain buffer. So after the unity gain buffer, the data is fed to another op-amp that is wired as a comparator. And the output of the comparator I am viewing in the oscilloscope. So let us see the results. So as you can see here, this is the data signal. This is the original data signal. And this is the final modulated signal after the op-amp. So after the op-amp comparator, you can see this is the final result. So if you compare both the results, they are nearly same. Both the results are nearly same. I am trying to compare them. You can see both the results are nearly same. Only thing is that the pulse widths have reduced. Here have reduced. So this needs to be tested. Actually, I did not test it with Arduino Uno because it is generating a voltage of 9 volts. So I need to design another circuit so that the amplitude of this waveform will be reduced. Some clipper I want to design. So you can see here this is the output after using op-amp comparator. So let us see the output after the envelope detector as well. I am pausing the video and I am taking the sample. So here is the data comparison between the main signal and the output of the envelope detector. You can see both the signals are pretty similar. Only thing is that here there is a capacitor discharge. That's why you can see there is a turn in the curve. But but both the signals are pretty similar. For the positive edge detection, you can see if I compare both the signals, they are almost similar. You can see they are almost similar. So if I clip out the negative part, then also this design can be helpful. So maybe in the next video I am going to enhance the circuit further. So for now, this is the result. So I have just changed the amplitude and I am seeing the two signals again. You can see, so this is the input signal, this is the main data, and this is the output after the demodulator. So if we can use a clipper, I hope we can get good results. So maybe in the next video I am going to enhance this design again. So the circuit diagram I am going to discuss now. So this is the timer IC555 timer wired in stable multivibrator mode, and here is the modulating data signal coming from the Arduino Uno transmit pin. So here is the modulating signal coming, and from here we are getting the final modulated signal. You can see 48 kHz is punched inside the data signal. So this output is desired at pin number 3. Finally here you can see there is a demodulator. I am using envelope detector. So in the previous video I was having only 100k resistance and I was seeing some bad waveform. So now I have enhanced here. I am using 25k resistance with a 0.01 microfarad. Possibly I will reduce this resistance further in the next video. And now from the output here you can see I am using one unity gain buffer. This is used in order to prevent the loading of the signal. And from here finally I am using I am using the op-amp as comparator. So finally from here we are getting the modulated signal. However, the output here is very satisfactory, and maybe in the next video I am going to use a clipper here and I will observe the waveforms. So for now, let us see the waveform again. So this is the result. So in the next video I am going to use a clipper and I will clip off the negative half, the unnecessary half. Thanks a lot. Thanks for watching.